Today, in this session, we'll see three subtopics of stress-life approach. One is SN curve, parameters affecting the endurance limit, and parameters affecting the fatigue strength. Initially, to start with, we'll see how SN curve was evolved. It started with the gentleman Wöhlers, who was studying the failure of axle in the railway way back when it was introduced as one of the road transport mode. He was the first to study fatigue of railroad axle and created the concept of the fatigue endurance limit. And his systematic study has resulted into the stress life or SN or Wöhler's curve. Later on in 20th century, a committee was organized for fatigue research. This committee later became ASTM, American Standard for Testing Material Committee E9 on Fatigue Studies. To understand how the SN curve is generated, it is basically use a nominal stress range as a measure of the severity of fatigue loading. And for a given stress level, it is repeatedly applied till failure occurs into two pieces. Then a series of tests are conducted at a different stress level, and the point of failures are joined together to construct a SN curve. It's not only done for smooth specimen, also it has been done for individual components or sub-assemblies or for complete structures. Now this is a typical SN curves for ferrous and non-ferrous material. One can see that in ferrous material, there is a distinct knee point at 10 to the power 6, whereas there is no such knee point observed in aluminum alloy. It keeps on decreasing asymptotically. It brings it to a two different definition. One is called endurance or fatigue limit, below which we'll have a infinite cliff. But in the case of aluminum alloy, since there is no endurance limit, it is usually termed as a fatigue strength, which will withstand without failure for a given number of cycles. And for aluminum alloy, the benchmark is 5 into 10 to the power 8. And this shows the typical experimental results of 1045 steel as well as 20246 aluminum alloy. So the stress life was first approach used to understand and quantify metal fatigue. It was a standard fatigue design method for more than 100 years. The SN approach is still widely used in design application where the applied stress is primarily within the elastic range of material. The stress life method doesn't work well in low cycle fatigue, where the applied strain have a significant plastic component. So this brings to the characteristic of SN curve, which has got three regions. One is called the first one is low cycle fatigue, where it takes less number of cycles to fail. Then the failure that occurs within 10 to the 3 to 10 to the 6 cycle correspond to the aeronautical applications. And the third one is unlimited fatigue range, which is below the endurance limit. Now we'll see what are the factors affecting the endurance limit. Usually, the SN approach estimates the total fatigue life, including crack initiation and crack propagation. It requires the tests related to the geometry of the structure under assessment to generate SN curve, and also generate from smooth specimen test data. However, they are subsequently modified to reflect the effects of notches, surface condition, etc. of the real structure. Because the SN curve generated as a material SN curve, but once the component is manufactured, it undergoes various applications and process. So obviously, it needs some modification. The Marin who observed the actual endurance limit getting affected, that is generated through a specimen like S-E with the different knockdown factor like Ka, Kb, Kc, Kd, and Ke and Kf. and where SE is the actual endurance limit after the applying modification factor, and SB or SE is the endurance limit of the critical location of a component. So it shows that the SN curve, which is generated using mirror polish, quarter elliptical, quarter circular diameter specimen, but in actual component will have a different type of loading, different size and surface, and obviously if you want to have a reliability, that will affect the entire SN curve between 10 to the 3 to 10 to the 6, which is a high cycle fatigue. Please make a note where the other correction factor affects only endurance limit. However, the reliability affects both the stress at 10 to the 3 as well as stress at endurance limit at 10 to the 6. Now we'll see what are the factors affecting fatigue strength qualitatively. So your parameter that affects most is material effect, size effect, machining quality effect, chemical treatment effect, technology process effect, assembly process effect. To give some few examples, here is the example of aluminum alloy with no treatment and also with treatment of acidic uh, composition or treatment has been done. In that case, your SN curve will be reduced by 60 to 75%. In the case of steel and alkaline, depending on type of coating, whether aluminum, cadmium, you will have a different reduction factor in the fatigue life. But when it comes to the temperature in kernel, so at the initial value 400 degree, if temperature is beyond 400 to 500 or 700, there will be reduction in SN curve or fatigue life. So, but luckily, there is no temperature effect till 80 degrees centigrade. So, thank you for patience hearing.